All right, so now we got the same thing, just an introduction to set theory phase 2. So nothing too new, but we're just spending some time reinforcing some skills from yesterday, practicing them and getting really good at them. So we got sample space. That's the set of all possible outcomes for an event. Forgot to put the T right there. Oops. Probability is a number between 0 and 1. All right. It's between 0 and 1. All right. So like 63%. Realize that's actually 0.63. You could even say like 1/4 or like 5/7. All right. The most likely something can happen is just 1/1, which is 1, which can be written as 100%. So all probabilities, all likelihood of an event happening is always between 0 and 1. And how do you determine that? It's the number of desired outcomes over the outcomes in a sample space. So say if you need to draw an ace, you're playing a card game and you need to draw an ace. Well, there's 4 aces out of 52 cards, and then you could translate that to some decimal and then some percentage, all right? I guess I got a calculator right in front of me. So like the percentage of just randomly drawing an ace is 0.7 or 0.0769. Then you times that number by 100 to get, so it's about 7.69%. All right, all those numbers are between 0 and 1. All right, so rolling a dice, the sample space for that is just literally 1, 2, 3, 4, 5, 6. Flipping up coins, heads and tails. High schools in Hilliard. You got DARBY. You got Brady Bradley. And you got Daddy's Money Davidson. All right. Now, determine the probability of each of the following situations, rolling it an even number. So the probability you roll an even number is the probability you roll an even number over the I don't want to write it like that. It's just going to be the number of even numbers, over the total amount of numbers. And even numbers, there's 3 of them, 2, 4, 6. Total numbers, there's 6, so it's 1/2, which you could write as 50%, or even just 0.5. All right, all of those, well, we want the reduced fraction. All of those are legitimate answers. Flipping a heads would be the number of heads on a coin, which is just 1, over the number of sides, which is 2. So there's 1 head, 2 sides. So again, that's just the same thing, 50%, or you could even write it as 0.5. And moving to a random Hilliard house and going to Darby. So the probability of going to Darby is the number of Darbys in the district, which is only 1, over the total number of schools. So 1/3, or about 33%, if you want to round it like that. All right. And then we got a challenge problem. Which combination of events is least likely to happen? So we're flipping a coin right here. Heads, tails, 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 tails, heads, tails, heads, 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 tails, heads, tails, tails, heads, 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 heads. Which event is least likely to happen? So pause the video, think about it. I'll reveal the answer here shortly. Here's the answer. They're all the same. All right, and this is something we're gonna elaborate more on in the future, but we got heads, there's a 1.5 or 1/2 chance of that happening, then a half, then a half, then a half. It doesn't matter, since the order's determined, they're all the same, all right? They're all a half, and I could keep writing the halves for the total amount. They're all gonna come out to the same likelihood. All right, so when order matters, each coin flip is dependent of each other. Again, this is more of a challenge problem right now. We're going to go in great depth in this in the future, but it's the same likelihood. Crazy to think about. All right, and then we got a two-way table, and we're going to interpret some information. All right, so the two-way table shows the number of births in thousands in the United States from the years 2010 to 2011. All right, a baby in 2011 is randomly selected. All right, so we're only focused on this column. All right, what is the probability that the baby was born in February? All right, so why I did this problem right here, it really has, we haven't talked about two-way tables, but I wanted to show you guys the point that if you just focus on how the problem's written, read it, and interpret it, we can do it. There was 299 babies born out of 3,966 in February during the year 2011. All right, so you could enter it as a fraction, or you could round it as a decimal. So you could say about 0.075 times it by 100, or you could even say 7.5%. All right, and then this last one, talking about sample spaces again, Frank wants to conduct a survey to determine the types of dogs that people like the most in Hilliard, Ohio. Which sample population should Frank survey to represent the population of Hilliard, Ohio? All right, people that live in the Darby district? Well, what about the people that live in the Bradley or Davison district? They're not represented, so that one's not good. People that work out at the YMCA? Well, there's other gyms in Hilliard, Ohio. There's Planet Fitness. Maybe you just work out at Darby. Random people that attended South Darby Elementary. Even though that is random, it's only South Darby Elementary. There's far more elementaries. It's a proven fact, though, South Darby produces the best athletes. Or random people that live in Hilliard. That's the one you want. Just random people that live in Hilliard. That's going to be the best representation. Is you just want a random sample from as much people as possible. All right, and that's it.